Okay, so now that we know how to add and subtract integers, let's talk about simplifying expressions that have like terms. So I'm sure that you've seen this before, but it's an important concept that will come up again and again, so it's important to be really comfortable with it. Basically, the idea is that each set of different types of terms in an expression like this becomes kind of its own game if you're using the scoreboard method. So we want to be able to add together numbers that we can to combine them so that we have an expression that's simpler and easier to work with. And so we're going to try to write this to be shorter, but we want to make sure that whatever we end up with is equivalent to what we started with. And what that means, equivalent, means that for any choice of whatever numerical value x might have, the results of doing this expression should be the same as the results of our final expression. So let's do the like terms for this expression. So we can see that we have two different sort of types of terms. We have some terms that have an x in it, and we have some terms that don't have an x in it. And so if you wanted to use the scoreboard method, you would need to make two separate scoreboards for each of these sort of types of terms. But because it's not too complicated, you probably don't need to write that whole thing out, and instead you can just recognize these two terms are like terms because they have the same variable. And these two terms are like terms because they're both just sort of regular numbers with no variable. So I like to kind of circle the terms that I'm going to use or indicate them in some way that's different from each other so that it's easier for me to tell how to combine them together. So I'm going to start with these two that are both with x, and I'm just going to combine them together, paying attention to the numbers and keeping the variable. So 3, and then this is plus 7. So 3 plus 7 makes 10. So I have 10x. And then the other two terms I have are 2 and 8. 2 minus 8 is negative 6. You could think about the negative team wins by 6. You could picture an arrow going forwards 2 and then backwards 8. Either way, it's negative 6. So I could write 10x plus negative 6, or just 10x minus 6. So 3x and a 7x gave me a 10x. 2 minus 8 turned into minus 6. That's the same as plus negative 6. Either way you want to write it would be totally fine. What we call standard form is when we usually write the terms with x's before the regular numbers. And then when we get to expressions like this that have an x squared, we write the highest power of x first and then kind of go down from there. Let's show that these two expressions are equivalent to each other. So we're not going to do this for every single example, but let's do it at least once so that you know what I'm talking about. So I'll grab a different colored pen. Let's do a little check here. And it should work for any number that I choose for x. So it's usually helpful to not choose 1 because you might accidentally come up with things matching when they might not always match. But this isn't always a guarantee. You could have them sometimes come out to look the same when they're not always going to be the same. But it's still a useful demonstration that we should get the same answer either way. So I'm just going to choose an example of x equals 4. And I'm going to put 4 in for x in this first expression that I started with. 7, 4, minus 8. So for every x, I put in a 4. And I'm going to see what this comes out to equal, which is called evaluating this expression. We're going to get a numerical value. 3 times 4 is 12, plus 2, plus 7 times 4 is 28, minus 8. Okay, and now I can add up these numbers. 12 plus 2 would be 14. 14 plus 28 is 42. 42 minus 8 would be 36. So this should equal 36. Is that right? I think I did something wrong. Well, let me double check. So 12 plus 2 is 14. Plus 28 minus 8. Yeah, it should be 34. 14 plus 28 is indeed 42. Minus 8 is 34. So 42 minus 8. This comes out to equal 34. All right, that's a good lesson in not doing too much mental math at once. Write out the steps if you need to, or check on a calculator if you need to. We do get 34 from putting in 4 for x in this expression. Or we could put in 4 for x into this expression. So that should be 10, 4 minus 6. So 10 times 4 is 40, minus 6 is also 34. So what this is showing us is that when I chose x to equal 4, the original expression and the final expression came out to be the same number. And if I were to choose a different number for x, they should still match, no matter what number for x I choose. That's how we define these expressions being equivalent, meaning any number we choose for x, they should always agree with each other about what the final value is. But you can see that it's a lot easier to get that final value using this expression than it is using this expression. This is just simpler, it has fewer steps involved, so this is an easier expression to work with that will always give us the same answer. So if we start with something like this, and we want to make less work for ourselves, we can use the like term rules to turn it into a shorter expression that will always agree with the original. Meaning we can use this one instead of the one we started with in pretty much every situation. And these same equivalents will work for any of the other examples that we do, but I'm not going to check it every time because the main focus of this video is just on how to recognize and combine like terms. But let's write this down in sort of our rules summary here. So, final expression is equivalent meaning it agrees for any choice of x or any other variable. Okay. And we also saw that to combine, the terms must match their type. And we will, as we go through, kind of articulate a little more clearly what that means to match the type. It's not enough to just ask, does it have an x or not? Because as we'll see in this next example, all of these terms have x's, but they are not all like terms. And that's because of this little number here, the exponent. So this is x squared, meaning x times x. So this x has an exponent of 2. And these two terms in the middle here have an x with no exponent written. And this last term also has an exponent of 2. So, it's not enough to just notice whether it has a variable or not. It needs to match the exponent as well. So, for example, this x squared term would be a match with this minus 4x squared term. And this x squared does not have a number in front of it, but hopefully you remember that if there's no number written in front of a variable, which we call a coefficient, if there's no coefficient written, then that's the same as there being a 1 here. So for the x squared category, we're going to do 1 minus 4. 1 minus 4, forwards 1, backwards 4. That's going to end up being negative 3. Or you could think about this as being the negative team of this game, the x squared game, winning by 3 points. And what game was this that we were playing? This was the x squared game if we were doing the scoreboard. So that means this gets an x squared. Lots of times students are tempted to do something with this 2 number, but we kind of already used it. We used it to decide that these two terms were a match. We don't have to do any other math with this 2. We should keep it. It's kind of labeling this negative 3 as being the result of the x squared category, or the x squared type or game, whatever you want to think about it. But we don't add the 2's together. We don't multiply them together. We don't leave them out. We just keep it as it is. Okay? And now these two are like terms, a negative 2x and a 5x. So negative 2 plus 5 is positive 3. So this is going to be plus 3x. This doesn't become x squared because we had 2 different x's combined together. We are adding, and anytime we're adding or subtracting, we keep those exponents, whatever they are, or if they're not there, we don't add them in. Okay, so this would be the final answer for this expression. So let's kind of summarize how we can recognize the like terms. So one type is no variables, just these regular numbers like 2 and negative 8. Or if they have the same variables and the same exponent. Okay, so for example, this one and this one have the same variable and the same exponent. These two had the same variable and no exponent, which is kind of the same idea. And then to get the result, we keep, so we add or subtract the coefficients, meaning the numbers in front, and we keep the variables and exponents. We don't combine them or anything like that. We match them and we keep them. So we look for matches based on the variables and exponents that we see. We combine those coefficients together, these numbers in front, and we keep these variable parts the same. So let's look at an example that has more than one variable. So here we can see we've got these different coefficients. We have some with x's, some with y's, and this one that has x and y. So the first thing we should notice is we're subtracting a group. which means we need to sort of distribute this minus sign. If you watched the arrow video, you know we kind of have to flip all the arrows that are part of this group, or you could think about it as this subtraction forces all of these terms to change teams. So I'm going to rewrite this as 5xy minus 6x minus 3x, because this minus turns this into minus, and then this is also going to turn this one into minus 2y, or you could write plus a negative 2y. Okay, so we're here. I really recommend doing this rewriting step and not trying to do it in your head, because you'll be thinking about which terms go with what, and it's really easy to forget this. So it's much easier to do if you already have it written down. Now we're going to look for matches. This has an x and a y. And there aren't any other terms in this expression that have both an x and a y. Likewise, this one has just a y, and there's no other terms here that only have y and not also x. So these two terms, even though they both have y, are not a match. And these two terms on the inside have the exact same set of variables and exponents. So the only matches are these two terms here, minus 6x and minus 3x. So you could think about this as negative 6 minus 3, or you can recognize that these both belong to the negative team. This is going to give us a minus 9x. So I'm going to write 5xy minus 9x minus 2y. And there's not really anything else I can do with this, because none of these terms are matches with each other. Even though we have some of the variables the same between them, they all need to match. So in this rule about the same variables, they need to match all of the variables, or it's not a matching like term. Okay, we got one more example. This one has variables a and b. It doesn't always have to be x. And most of the terms don't have any exponents, but this last one does. So let's go on a hunt for some like terms. I have this one here that only has an a. And I see this one here that also only has an a. And both of these do not have any exponents, so they are a match. So I have 3 minus 5. 3 minus 5 is negative 2. Negative team wins by 2, if you want to think about it that way. Or forwards 3 steps, back 5 steps. You're just going to be backwards 2 steps. So 3 minus 5 is negative 2. And then I'm going to write the a, because this is the outcome of the a terms. I'm not going to write a squared, even though there were 2 different a's written here. I just keep that variable the same. Okay? These terms are done with. Now I'm going to look at this term, b. And I see another term that happens to be an exact match. So I'm going to take these 2 terms and put them together. Now try to remember, because there's no coefficient, no number written in front, it counts as a 1. And so this becomes 1 plus 1, which is 2. So this would be plus 2b. These now are done with. And then at last we have this one that has a and b, and we have this one that has a and b. But if you notice, these are not actually a match, because this a does not have an exponent, this one does. So these 2 terms can't be combined. We can't do negative 4 plus 2 to get negative 2. It's not allowed. We're just going to keep these terms as they are. So minus 4ab plus 2a squared b. With the examples that just had one variable, x, it's a good idea to write the terms in order of highest exponent to lowest exponent of x, and then ending with whatever numbers don't have any variables. When you have more than one variable, like these other two examples, it's a little harder to do that because they're kind of mixed together, so there isn't really a specific order that you need to write it unless the question specifically asks for it. But it's important to recognize that this would be an equivalent expression if we were to shuffle around the terms. It would still work the same. Okay, so to review, let's do a couple of quick examples of just deciding whether two things are like terms or not. So if I have 1/2 x and negative 4x, what do we think? Are these like terms or not? Yes, they are. They have the same variables. They both don't have an exponent. It doesn't matter that this is a fraction, it still counts. These are like terms. Okay, what if we had 3xy squared and negative x squared y? Okay, so we have an x, we have a y, we have a squared. It feels like we have all the same ingredients. But here, the exponent belongs to the y, and here, the exponent belongs to the x. So these are actually, yeah, I'll write like a big X, not like terms. Because even though they have the same variables, each variable needs to have the same exponent as it does in the other term in order to match. Okay, let's do another example. So let's say we have 4z squared x cubed and 2x cubed z squared. So this has a z with an exponent of 2. This has an x with an exponent of 3. This has an x with an exponent of 3 and a z with an exponent of 2. Yes. These two are like terms because they have the same variables, and each of those variables has the same exponent that it has in the other term. So this z has an exponent of 2, so does this one. And this x has an exponent of 3, so does this one. So these are still like terms, even though the variables are in a different order. What a term really is just a bunch of things multiplied together, and the order that we multiply things doesn't matter. So these terms are like terms. Okay, I hope this was helpful. I hope it made sense. I'll be back with another video pretty soon. Hope you're having a great day.